And here we are live now, and we'll talk about Seaboard, whatever that is, and Eric will give us an introduction to what this format is and how the APIs will work.
Okay, thank you, Imo. So I'm just gonna start by sort of giving an introduction of what Seaboard actually is. So Seaboard, which is like an acronym standing for Concise Binary Object Representation, is a binary data format loosely based on JSON, which emphasizes small message sizes, implementation simplicity, and extensibility without the need for version negotiation. And basically, this proposal is to provide a generalized Seaboard reader and writer as a public API, which will live under the system.formats.seaboard namespace. So basically, a few words about the actual format itself. The format defines a data model that largely derives from JSON and slightly extends it. So introducing terminology here, a data item consists of a single piece of Seaboard data. The structure of a data item may contain 0, 1, or more nested data items. And each data item can be any one of 8 distinct major types. Again, that's terminology used by the spec itself. So I'm just going to enumerate the major types for the benefit of the audience. There's major type 0, which is an unsigned integer encoding up to 64 bits long. Major type 1, which is a negative integer encoding up to 64 bits long. Major type 2, which encodes a byte string, which may or may not be length prefixed. Major type 3 for Utf-8 strings, again, may or may not be length prefixed. Major type 4 defines an array of data items, very much in the sense of JSON arrays. So elements can be of any type. And again, you see a pattern here, can or cannot be length prefixed. Major type 5 is a map containing pairs of data items, essentially a JSON object. The main difference from the JSON object is that actually keys in Seaboard can be of any major type, not just string, which leads into some interesting APIs in this proposal. Major type 6 basically defines a semantic tag that can wrap any nested data item, which is basically used to denote a specific meaning to payload. So tagging, for example, a string with tag 0 means that it's a datetime string under a specific format. And finally, there's major type 7, which actually contains 2 kinds of values. Basic floating point numbers, which can be half, single, or double precision, or they can be any one of byte-sized simple values that require no additional content, such as false, true, and null. And these can be extended via a simple value registry as defined in the spec. Are there any questions so far?
No, that makes sense. I mean, I think you might have mentioned this, but where do we use Seaboard?
Yeah, so I have some notes on the motivation for including this. The primary motivation is that we need to implement the CTAP protocol. CTAP stands for Client to Authenticator Protocol, which is part of the FIDO Alliance, and we need this for ASP.NET Core, apparently. That's sort of our only use case for now.
Yes, it's for me, Imo. So those little YubiKeys that you have that allow you to hardware auth to GitHub, to your own AAD and the like, they are using Seaboard. Well, the browser uses Seaboard underneath to provide structures to sign and validate and send to the backend. So it's for the FIDO2 support that we want to put into ASP.NET.
Gotcha.
Yep.
There are some other things that use it, but that's the only immediate consumer.
And that's why we care, basically.
Yep. That's why we care right now.
Okay, so if there aren't any questions, maybe we can continue. Could you scroll down, please?
I just had one related question to that. So we have effectively one consumer. We feel like the use cases for that particular consumer have appropriately led to APIs that are going to be usable in other situations in the future?
Well, I mean, for that, like we have actually written a basic application for serializing and deserializing COES keys, which is sort of the main application that we'll be using it for. That being said, it's a proof of concept rather than something that I would consider, production worthy.
Okay.
Does that make sense?
Yeah, I think you're saying we believe it's sufficient for any particular need.
Cool. So just continuing with some of the details from this Seaboard format itself. Each data item encoding starts with an initial byte. Again, that's terminology from the spec. It's not particularly imaginative in its naming, which contains the major type, the high order 3 bits, and additional information, the low order 5 bits, which are dependent on the actual major type of the initial byte. And so the additional information basically just determines if any additional bytes might be required for the data item encoding. And this basically allows for small values such as 0 or the empty array to actually just be encoded using the initial byte only. Generally, the spec also defines a diagnostic notation, which basically lets you render Seaboard values using a JSON-like syntax. So I've included an example here in the design doc. So this basically defines a Seaboard map, and it sort of showcases a key containing an integer value, hex encoding byte string, a nested array containing null and Boolean values. Key 4 in particular is sort of an integer value containing a semantic tag, and that's actually representing a Unix time. And finally, the final key basically demonstrates that keys can actually be of arbitrary type. In this case, the key is a Seaboard array. And as mentioned earlier, like Seaboard is the messaging format used by FIDO and the CTAP2 protocol. And we need this for ASP.NET Core. Another thing is that RFC 7049, which is basically just the Seaboard spec, I'm using this number quite a lot, it defines 3 basic levels of encoding conformance. So well-formedness, which basically guarantees that the document is in fact a well-formed document. That's kind of a circular definition, but it means that it's syntactically sound, if that's the right terminology. Then you have strict mode, which adds a few additional constraints. For example, maps cannot have duplicate keys, and any Utf-8 string must actually be a well-defined Utf-8 string. And then you have canonical Seaboard, which adds additional constraints on top of that. For example, that keys in a map must be sorted in a particular way, plus certain other canonicality conditions. And obviously, if you're interested, you can click on the links and see for yourselves. But what's more, the CTAP2 spec defines its own set of canonical Seaboard encoding rules, which are very similar to canonical Seaboard in the Seaboard spec. However, it contains slight differences, for example, in the sorting semantics for keys, etc., etc. So the proposed implementation here would be to add all 4 of those conformance levels to both the reader and the writer. So that kind of concludes sort of the introduction to what Seaboard is and what we need to implement. Moving on to the certain basic examples that demonstrate how the proposed API will be used. Now, the first example is just a very basic piece of serialization logic, which happens to be a simplification of the example that I mentioned earlier, like serializing a COES key, elliptic curve public key. I have included in diagnostic notation an example of one such key, which has been basically just copied and pasted from the RFC that defines that format. But if I wanted to actually serialize this in the Seaboard format using the proposed API, here is a method called create EC2 code key encoding that accepts, a basic set of parameters and performs the serialization for you. So, in the third line, it initializes a new Seaboard writer instance with the CTAP2 canonical conformance level passed into it. And then, in the line after that, it pushes a definite length map context with length 5. This is because for the purposes of this example, we know a priori that the length of the map is going to be 5, so we can declare this. Then we're writing a bunch of key value pairs. In the case of code keys, key types must always be integers. So, you see that the keys are actually written using the writeInt32 method. And finally, the public key point is written using the byte string method. And finally, once all the data is written, we're popping the map context and returning the encoded byte array in Seaboard form. So that should be pretty straightforward, unless there are any questions about that.
So basically, the API that you have, given the title, is basically reader-writer, right? So like, is my mental model that this is similar to, let's say,
yes,
XML reader-writer, which is like streaming forward-only kind of thing, right?
It's forward-only, stateful, that kind of thing, both for the reader and the writer.
And how do we? So you said there's some restrictions that we have. Do we have like? Will the reader have support for enforcing those? Or the writer, I guess.
You mean for the conformance levels?
Yes.
Yeah, so that is actually specified in the third line, like in the first line and the method body, where the conformance level is passed using the Seaboard conformance level enumeration. So, so that means a couple of things. First of all, the writer will ensure that the conformance is observed, and in cases where it cannot, it cannot do this, for example, because a user pushes a duplicate key, then it will throw an invalid operation exception.
I have one question as well. So I'm looking at the code you kind of shared in here, and I'm seeing the right start map and the right end map. And my question is this kind of implies the scope for writing the map, which kind of feels like there should be kind of some abstraction to kind of make it easier for users to kind of not forget about the end and other things. I'm just kind of curious if you've considered.
You mean like an iDisposable token?
Yeah, basically something like that. Like.
Yeah, I kind of intentionally avoided that because I dislike the fact that it will be executed even if there's an exception. So I kind of rely on people remembering to do that.
I'm not sure I follow about the exceptions.
So if I understand your proposal correctly, is that basically write start map should return some kind of iDisposable token that I could bind to a using declaration so that it would pop the map context automatically as soon as the method leaves the scope. Is that correct?
An example, yeah. I'm just curious if you've considered this like design, like.
Yes. Yes, and I thought about it, and the reason why I didn't implement that is because an iDisposable will be executed regardless of whether the operation was successful or whether it threw an exception. Because I only would expect this to be done in the happy path, I kind of feel that iDisposable is not the right abstraction for this kind of use case.
Yeah, I would call out that XML writer and UTF-8 JSON writer both made the same decision.
Okay, fair enough.
I mean, I'm not sure they made that decision. I would almost say they probably didn't consider that because this iDisposable for, pairing operations is kind of a philosophy or I guess a pattern that has evolved, I think, after the V1 APIs were shipped. But I agree with Eric's reasoning. I understand the syntactic appeal of it, but if we were to do it, we would probably have to do some special casing in the dispose and saying, if error occurred, don't write it, because otherwise you have risk for eating the exception effectively by throwing from the finally handler, which you don't want, right? So let's say you push a write in32 API, you call write in32 before, and then you get an exception like duplicate key or something, and then then because you leave the scope, now you call write end map, and that throws now an invalid operation exception and basically masks the other one, right? Like that would be pretty bad. we could still make that work, but like then the question is like how much is syntactic, cuteness.
I'm
worth
not
to
sure
you?
whether it's worth the
Yeah.
complexity, and like this is meant to be a really low level thing, so I wouldn't care. Probably is the right verb for that.
Yeah, I mean, conversely, I did add it for ASN Reader, and it does clean up this. It does make the code easier to read when you end up with a lot of the small scopes, but I can agree that things like the fact that the meaning of write int 32 changes from key to value depending on the number of times you've called it, and that some things are not valid as keys means you probably do have more failure states here that are useful to share, but we can talk about that when we get
Right.
to those methods.
So I guess reading a map will be good
Yep.
thing to look at now.
So here I have a very basic example that illustrates how a Seaboard map can be read, and for simplicity reasons, I'm just going to assume that all keys and values must be text strings. So here I have a method called read Seaboard text map, which accepts an encoding and returns a dictionary that obviously just contains the key value pairs. So here in the second line in the method body, I initialize a Seaboard reader object, which again accepts the input encoding, and for the purposes of this of this sample, I'm setting a strict conformance level, which is just a reminder that's slightly weaker than canonical conformance level. And then I'm calling the read start map method, which returns a nullable length value. So the nullable result basically, if it's populated, it denotes the fact that the map is actually definite length or length prefixed, if you prefer. And if it is null, it likewise determines that the map is indefinite length, and therefore I would have to traverse through the entire map before I know what its actual size is. So here I have a basic piece of code that handles both cases, just for illustrating how it works. If it is actually definite length, then I can just simply create a straightforward iteration that does length number of reads, and using the read string method for both the key and the value. And on the other hand, if you have an indefinite length map, then you would basically have to peek the reader state every time you finish going through a key value pair until the reader state reports that we're at the end of the map, in which case we are done and we can pop the map from the reader state and return the results.
That makes sense. And then
Okay.
I guess like in at the beginning of the while loop, you could also say reader.peak stake, and it would tell you that the next thing is a string.
Yeah, it should return string in all the other cases.
Okay, so that means I can actually read the entire map even if I don't know the format of the map.
Yes. So that's a explicit design goal. Like, you should be able to read through any well-formed Seaboard document, even if you don't know what its shape is. If that was the question.
Yeah, basically.
Okay. Cool. So unless there are any questions about that, shall we move on?
Seems pretty straightforward so far. I mean, Jeremy has probably more context. Do you want to poke any holes, or do you want to wait?
I'm good so far.
Barry, you're happy what you see? I suppose.
I mean, yeah, this is ASP.NET's not going to expose it like this at all. It'll just be me using it, and yes, it will be a PM code sample to begin with, which should horrify absolutely everybody. So it's me that has to use it, because we're not entirely sure how this is going to work with the web stuff yet. It's really hard for me to say if this is usable or not. And of course, my view of usability is mollified by the fact that I can basically demand that Jeremy helps. So I have a slightly easier time of it than anyone else would want to use it raw, but it looks fine. I mean, my scenario really here is I want to get a bunch of signing keys out of the encoded stuff. So if I just get a decoded thing and say I want that value right over there, that's all I really care about.
Yeah, and you have it easy because the CTAP2 conformance says everything has to be indefinite length, so you'll never have to write the while.
Yeah, writing is not my goal here. All I care about is reading. So yeah, I can't really give a considered opinion on anything other than that. But the read stuff looks fine.
All right then. Let's look at requirements and see whether we agree with those.
Okay, so goals. So first of all, provide a stateful forward-only reader class that can read Seaboard encoded data, and ULE do the same thing for writing Seaboard encoded data. As stated before, both reader and writer must support the following conformance rule sets. So basic well-formedness, which we'll be calling lax conformance. RFC 7049. RFC 7049 is just the Seaboard spec. So strict mode, canonical mode, and CTAP2 canonical mode. So these four. The reader should allow schema agnostic scenario, which is pertinent to, Emo, your question from before. It should support reading and writing indefinite length data items, and optionally, the writer should allow on-the-fly conversion of indefinite length encodings into definite length equivalents. Basically, that means that if you have opted into this behavior, the writer will auto-convert the encoding in your buffer once you've finished writing your indefinite length array or map or string. Support tagged value formats as defined in the Seaboard RFC. So basically, the RFC itself defines semantic types for a certain number of values, and for those values where we have equivalents in the .NET library, we provide writing and reading logic. So for system data type offset, big integer, and decimal values. The reader should have support for skipping any data item, which would include its nested data items as well, and just discarding the result. And that should basically provide a workaround for advancing through non-conforming sections of the encoding, if that makes sense. So the scenario is that you're reading through a piece of Seaboard and suddenly you come across a map in which the keys are not sorted or something. So the skip implementation in this case should be able to still advance through the encoding, provided that it's well formed. And another goal, which is mostly technical rather than functional, exception safety. So methods that throw should not have any side effects, if that wasn't obvious. So are there any questions concerning the goals? Okay, so I'm just going to move to the things that we don't want to do. So we don't want to add support for automatically serializing or deserializing between Seaboard data and .NET types. It's just going to be the basic writer and the basic reader. There will not be a Seaboard document-ish type that would be used to represent, the Seaboard data model. There will be no support for converting data between Seaboard and JSON. And the reason why I mentioned this is because the Seaboard spec actually devotes a certain part of it to that specific functionality. We won't be doing that. No support for reading or writing from Seaboard Diagnostic Notation. And finally, probably more controversially, no support for writing to or reading from system.io.stream.
Interesting. So you only support basic byte arrays then?
Yep. And the reason, I would like to see System.io stream being added eventually, but many of the features that we added, for example, even the fixing up of indefinite length encodings, necessitate that you have the entire buffer in memory, and you should be able to modify it at any point in time. So we just dropped this.
Jeremy, does your ASN thing support streams, or is it also just byte arrays?
I mean, similarly, so with ASN1, it always has to do the backwards writes, because essentially the model that we added here for letting you write an indefinite array and then we turn it into a definite array for you after the fact is the way everything has to work in the ASN writer, because while this model uses the count of items, the ASN data models use the count of bytes. So you seriously didn't know that until you were done writing everything down. So since the writer doesn't support streams, the reader doesn't support streams, and certainly support for those things could be added on top. Someone could write a stream thing on top, but they would lose some of the functionality or depend on fully seekable streams. But it's weird to talk about inserting a byte in the middle of a seekable stream. It would require a lot of out-of-band buffering.
Right. Yeah, I mean, to me, it seems not a deal breaker. Like, I don't even think it's that controversial. Like, it depends on how big the payloads are, right? If you expect to process a Seaboard document that is 4 gigabytes in size, then not having a stream is kind of a problem. But if everything is effectively on the order of a few pages, then I don't think it matters.
Yeah, we don't really have any use cases where, we know that we need this.
I mean, my only question
is,
is,
are tiny.
Yeah, my only question is, if we were to add it later, like what would fall apart in the public API? I mean, obviously it would have an overload that takes a stream, but is there anything else that would have to change?
So there would be more failure modes. So if you wanted to opt into certain of the functionalities that Seaboard does for you right now, that would have to throw if you were to use the stream APIs for the reasons that Jeremy mentioned.
I think if we were to add stream support for either of the, let's call it 2 formats libraries, it would end up being types that wrap the ones that work on buffers so that it can drop out the functionality that won't work. Instead of having these methods throw an invalid operation exception of, I'm sorry, you used the stream constructor, I'm not allowed to do that. Or, I'm sorry, you gave me a non-seekable stream, I can only do forward writing. And yeah, so someone could write the stream writer on top of the current writer, just as long as they gave up on features.
Seems
but
fine.
I think the biggest payload we expect right now is, I'll be generous and call it 2 kilobytes.
Yeah, I mean,
the purpose of this model is to be small, and so having something that would take 4 gig to serialize, you possibly just wanted something better. Like, you wanted a different thing so it was easier to recover from.
So you wanted YAML, is that what you're saying?
Yes.
All right, design.
Okay, so as you can imagine, there are 2 pillars in the design: stateful reference type writer, imaginatively called Seaboard writer. It allocates its own expandable write buffer. The writing is basically done via a suite of write bracket type methods for common types, in the shape that you would have expected from other, writer classes. And for composite constructs like arrays, maps, etc., the general convention followed is write start type and write end type. Likewise, stateful reference type reader called Seaboard reader. It decodes a user provided buffer. It exposes, again, a suite of read type methods for common types, and equally read start and read end. That should have said type, by the way. It says read end map for composite constructs. And another key feature is the peak state method, which is used to determine the next data item in the buffer without advancing the reader state. So this is basically the design of the proposed API. So unless there are any questions here, we can actually move to the actual proposed APIs. So let's start with API that's common to both the reader and the writer. First of all, we have the Seaboard conformance level enum, which, as mentioned before, defines the 4 supported conformance levels. So we have lax, which is just basically validates that the Seaboard data is well formed, as specified in the spec. That is also the default conformance level. So whenever you don't pass any arguments in either the reader or the writer pertaining to conformance, that will be the default. Strict for, again, Seaboard spec strict mode, canonical for Seaboard spec canonical mode, and then you have CTAP2 canonical for the canonical mode as defined in the CTAP v2 spec.
So I guess all these terms are coming from the spec. It just seems really weird that strict is not that strict.
So lax is our own terminology.
Okay.
The Seaboard spec uses well formed, but we just went with lax.
Any particular reason why you went with lax?
Parity with XML. It's softer than strict.
Yeah, but parity with XML is not a particularly good reason if we're talking about, descriptions that have come from the spec. Surely sticking to a spec description would be, I hesitate to say better, but would be more expected.
Right. I mean, Eric, in the spec, did it really call that out as sort of a thing? I know XML does talk about lax versus strict reading. I feel when I read the spec, it talked about the data language or the data model, and then said, and then there are 2 restrictions. One's called strict and one's called canonical. So it kind of didn't really talk about the default state.
Correct. Yeah, that's actually a good point. It is using the term well formed for valid Seaboard encodings, but it doesn't define as such a conformance level called lax. So maybe that might have been the initial motivation for this. But well formed is the appropriate term.
I mean, you could. It seems like well formed is the minimum anyway, right? You can't have less than well formed. In which case, you might as well call the conformance level none, which kind of means like it's
Well, there might be another point to add here. Actually, well formed is even weaker than the minimum conformance level offered by our implementation, and the reason is just because we want to be stricter than what the spec allows in certain cases. Like, for example, where lax might actually necessitate replacing invalid formats with the undefined tag, or not throwing errors whenever something else is encountered. So we've kind of taken the informed choice to make it slightly stricter, if that makes sense, because that was more valid in the .NET context.
So the couple places that we plan to use this, will we ever be using the lax level?
No. In the applications that we'll be using, we will have to explicitly use CTAP2 canonical mode.
Would it make sense to leave off lax? I mean, just the fact of UTF-8 strings that aren't actual UTF-8 is kind of scary to me. I wonder if who would be using this intentionally.
Yeah, I was kind of thinking about making strict the default, although I wanted to defer this conversation until this API review. But maybe the discussion about default should be made in the constructors rather than in the definition of the enum. I don't know what the best approach would be here, but I think strict might have been a good choice for a default. The only downside of that is that it's not the most optimal configuration for the reader in the sense that it's making key uniqueness checks, etc., which wouldn't be a big problem as far as I'm concerned. Any thoughts?
Yeah, I mean, essentially this, it does, well, I mean, there's a question of, does the reader, like if we say that the reader is reading strict, then it seems that the reader does have the responsibility instead of the caller to say that there were no duplicate items, which is a requirement of strict. And is it strict or canonical that says integers have to be included using the smallest form they can?
Yep. It's canonical.
Okay, so strict, yeah. Like essentially, lax is just right, or for the reader, lax is if you just went through item by item and just wrote a method that says I can read using like this, like I can read 2.6 and I have implemented 2.6. We're good to go. Strict is higher level stuff, and for the current, we put a little bit more power, or we can remove some checks and let someone get performant code where they assume correctness. Lax is don't do the redundant checks, just read the data.
I mean, if invalid UTF-8 strings is a valid concern, we could perhaps augment lax so that it makes that check as well. That could be another possibility.
Yeah.
Yeah, it's just a little bit weird that we have, ensures that it's well formed as specified in RFC, and then it's called lax.
Sure. I mean, if we think well formed is a better name, that's lax is. I mean, just again, a bunch of my usage of readers and writers is based on the newest tech being XML reader when I started using them. So it's, to me, lax just means well formed.
Okay. Do we have lax used anywhere other than XML reader, like the JSON readers or anything like that? Because if it's only in the XML reader, and it's actually a term that's in the XML spec, then you can make the argument that the term should come from the specs rather than from.
So it looks like the cookie same site mode has a value called lax.
Oh, well, that's in the spec.
And WCF has a lax security header layout.
I have no idea what that is, and it scares me already. The same site cookie one is definitely part of the spec. It's a term that's used in the spec, and I just have the feeling we should map spec terms as much as possible.
Sure. Okay. Is there any agreement with respect to what the default should be?
Strict.
Strict? Okay.
For both the reader and the writer?
Well, if we're talking about the writer, I'd say canonical because I'm evil. But either strict or canonical.
I would even suggest just leaving lax out unless we know that there are use cases for that.
Well, if it's a performance thing, I think we can call it the David use case. He's just gonna hear this and he's gonna go, what? But if it is a performance optimization, then it should probably stay there for people that already know that their validation has been done. So for example, you have a couple of internal APIs, you know that the caller is doing the right thing. I could see a use for it.
I mean, the one thing
I should probably note that. Sorry.
Yeah, it's the only thing I would say is like bleeding out seems problematic for an enum because you kind of want to have the more stricter rules to be higher values, and that means if we would leave out lax, it kind of means we leave out the 0 value, and that seems weird for an enum.
Right, because really lax is, as somebody else said, is we're not applying any conformance rules.
Right.
So it has to be Seaboard, but it's not adhering to any particular set of conformance rules. So the conformance is lax or non-existent or nearly non-existent.
Yeah, I mean, I think it makes sense. I'm not hearing like concrete use cases for it. I'm hearing like, hypotheticals, but how many people are actually going to be using this API?
Just Barry.
And yeah, if you were talking about how many people are going to use the API, then the only one that would be needed is CTAP2 canonical, and that's kind of silly because that's a very specialized case.
Yeah. Yeah, I feel like some people were commenting on some of the proposal issues that they're in IoT. There's a move to start using Seaboard stuff because it is definitely more compact than JSON. And
I should probably note that the lax conformance is the only mode of operation that doesn't entail allocations per context, because validation means that you need to keep track of, a lot more things. So there's definitely a performance angle to this as well.
Yeah, and for what it's worth, my eyes happen to latch onto the sentence, support of strict mode is not a requirement placed on all Seaboard decoders. So the spec suggests that, what you would write is lax.
Okay, I mean, I'm fine leaving it in if we think that the users who would use this API would either know not to use it or that they would be successful in doing their own validation.
Yeah, I think it makes sense to have, again, from Emo's point of picking something as the zero other than we don't have conformance here is weird. So no matter what, it has to be in the, I feel like it has to be in the enum no matter what.
Right.
Whether we call it lax or none or well-formed or well-formed only or whatever. We could have a different argument, which is that neither the reader nor the writer accept that value in their constructors. But I do think it would be weird to say that default of conformance level is strict.
Yeah. I mean, you could go with, you could make that work, right? You could say then lax or well-formed is -1, right? Like if you really wanted to, but it seems, to me, a tiny touch too on the cutesy side.
Yeah, I mean, the enum is not ordered. At least I feel like it's not. I don't think CTAP2 is a restriction of canonical. No. Canonical is a restriction of strict, and CTAP2 canonical is a restriction of strict, but they're not. You can't say one is more restricty than the other. They're differently restricty at that point.
Yep.
Oh, I see. I've got the impression that CTAP2 is more than canonical, because the naming kind of implies that, unfortunately.
That actually brings in another issue, that conversation we were having with Jeremy, whether canonical needs to be further disambiguated, because you have CTAP2 canonical and just canonical. There was initially that was actually called RFC 7049 canonical, which I removed, but I thought I'd bring this up here.
I mean, it depends on how you feel about this. I mean, giving both of them a prefix makes it probably easier to understand that they are both different kind of canonicals, rather than one is more restricted than the other. On the other hand, like if you expect other people to use the RFC 7049, then it's kind of weird that it makes it a little bit less approachable, I guess.
Yeah.
So when I was reviewing the PR, initially it was RFC something. So I personally felt like the RFC made more sense to me, because I could look it up what that means, versus after changing, I had no idea what that meant.
I think the issue is that it might be misleading in the sense that RFC is just a Seaboard RFC. So, there's nothing to it other than it being a mode that is part of the Seaboard definition. So that's why that was my rationale for removing it.
Yeah, because another name that we could name it is Seaboard canonical, since RFC 7049 is the Seaboard RFC. Now, granted, there could be an update later, and we get RFC 9152 canonical, which is a refinement of Seaboard canonical or whatever. So, but yeah, I didn't like Seaboard canonical, or I don't even know if it actually came up, but in my head, I don't like Seaboard canonical because it feels like we're doing the RTL or whatever ADO prefixes from enums in C, where the type name is not actually a part of the unique identifier. because we already have the Seaboard from the conformance level. But if we think that putting RFC 7049 as a prefix helps disambiguate it from CTAP2, that's fine. I agree with Eric. It felt a little redundant.
Well, in that case, you'd also have to do it for the strict enum as well, wouldn't? Or the strict value as well, wouldn't you?
Yeah, because theoretically, some other important spec could come along later, and we could have potato strict, which is different than strict. And so if we are concerned about the prefixless one not being clear that it means from the base spec, the argument I gave when Christoph brought up it seems weird to remove this prefix is, if we had written this just based off RFC 7049, we would have called them 0, strict, and canonical, and everyone would have thought those were perfect names, and then we would add support for CTAP2 canonical, and so this is what it would look like if it was an evolved API instead of a brand new API. Now, maybe this means we get better foresight because we're actually doing them at the same time, but
I mean,
it didn't feel too
also
wrong to
like
me.
enums kind of allow us to use the same like different name for the same value. So technically speaking, we could like just add another canonical, like RFC canonical later, and just make the canonical mean the RFC like later, basically. So just document it. This is the same as the other thing, so it's more explicit. Like if we actually end up in this situation.
So having heard the pros and cons, Emo, how do you personally feel?
I guess I don't care that much, because I guess no matter what, like, you have to still read up on what it means. So I guess it's fine. I was just laughing because I was reading chat and Kevin just said, I will certainly misuse Lex Seaboard. So you already have one consumer of it.
Yeah, I thought about asking him, did he mean he expects he'll get it wrong, or he expects to abuse the heck out of it? But
you know Kevin, so the
I
answer
didn't
is
until
obvious.
just now.
Yeah, I don't know. Like, I mean, generally speaking, I think like we try to make things approachable, and like what we know from usability studies is that simpler names will always be preferred. People say they want clarity, but very often when you have the choice between simple words and more complicated words, people assume the simpler words are what they want. And so if you expect more people to use canonical, then naming canonical makes sense. If you expect more people to use strict or lax, then naming it RFC is something. That's a very safe way to not get it picked up. It would be my guess.
I think the irony here of someone whose first language is German talking about not wanting to combine a bunch of words into one is quite hilarious.
Well, I mean, in fairness, name a German API that was successful.
You have your boat captain, don't you?
We do, but like, how many people in the world speak German again? That should tell you something about the success of that language. Even Chinese and Japanese is spoken by more people than German.
Enumerate Buchauterin?
Huh?
Enumerate Buchauterin?
Yeah.
Well, I actually had to choose a second language to take in grammar school, and so the one that was available was German, and so I was forced to take German, and I got the lowest score ever in that school in the German exam of 9%.
And that's when you decided security is really your profession, I suppose.
Oh no, that's a whole other story that will take a long time to tell.
I see. All right, then I guess let's go with canonical for now, and then unless somebody else feels super strong. I mean, given the number of people that will use this APIs literally on this call, like, it's just from a general principle standpoint, like, we try to have simpler names if we can make that happen. But it's not the only goal we have. Sometimes clarity is more important, so.
Okay, so shall we go on?
Then let's go with the Seaboard tag. Hopefully that's less controversial.
Well, it's pretty long, so the potential for controversy is
Getting up.
non-significant. Yeah. So basically,
One
basically
thing before we move.
Yeah.
Kevin just brought up in the chat that we don't have an ordering, but we called it conformance level, and he feels that level implies that it's tiers. So maybe we want to change level to mode.
Yeah, I would agree with that. That's a very good point, actually.
Thank you, Kevin.
But it's a security thing. So creating tiers is probably what we're. Oh, he means tiers with IE. Okay.
Yes. Not with EA. Those are included for free with every download. All right. Seaboard tag.
Seaboard tag. So this enum basically just represents the Seaboard semantic tags, which are unsigned 64-bit integers. This enum essentially defines a list of all the tags as defined in the spec, and using the wording used in the spec as well. That should probably reduce the controversy here. Now, do keep in mind that the tag registry for Seaboard is extensible, and we would expect people to typically assign new values within the Seaboard tag space, but this defines everything that exists in the Seaboard spec. For what it's worth, we only really use the first 6 tags for any semantic tag serialization and deserialization here. Everything else is just added for completeness. So date time string, Unix time seconds, unsigned big num, negative big num, and decimal fraction. So the first 5 rather. Decimal fraction are all used for types that we write and read. Imo, would you like me to enumerate all the other tags?
Can I use the big float here as an excuse to push through my proposal for actual big float in the runtime?
Yes, please.
The eyes have it.
So going on, again, base 64 Earl later encoding, that's literally just using wording from the Seaboard spec, is basically meant to denote byte strings that are meant to be transcoded into a base 64 representation in JSON. And that's generally the application of the later encoding instances in this enum. Amo, could you scroll down, please?
Wait, so is this just a byte buffer, or is it like an ASCII string that is already base 64?
So that's a byte buffer, but it's meant to be transcoded into an ASCII string. So the idea is that you are able to make a full back and forth from JSON to Seaboard. So basically, base 64 encodings are meant to be. So it's basically a byte buffer, but it includes this tag for transcoders to, make the association that, hey, this is a base 64 string.
Okay.
Does that make sense?
And these are actually, I was going to say it's a suggestion. In the spec, they're called content hints. And so all that base 64 URL later encoding really means is that it's the number 21, and it's up to somebody else to interpret the payload that it's wrapping. Of course, recommended thing for it to be wrapping would be a byte array, but that would be, if we had API that read it, then it would throw of like the payload made no sense. But if somebody's doing it manually, they'll have to deal with the fact that the tag carries with it no semantic reinterpretation of the thing. It's just a comment, basically.
Okay.
Yeah, and for what it's worth.
Go ahead.
Go ahead. No, after you.
Okay. Are these basically just an explosion of some bit flags?
Basically, I kind of blindly decided to define everything in the spec, but if people here feel that we could omit some of those, that's fine as well. There is no code in either the reader or writer implementation that use those particular later encoding tags.
It's not bit flags. There's just a list of this of 21
yeah,
means base 64 URL later.
Okay.
Yeah, they're not flags.
Yeah, it's just we have reserved this number for this suggestion of semantic meaning.
I mean, if you want to make a general purpose Seaboard reader, I think leaving things out is not helpful. You're almost going out of your way to make the API less useful at that point.
Yeah. But again, given the extensible nature of tags, leaving out something in the spec is like people just define it from. We'll just have to define it as they would have to do with stuff that has been added outside of the spec.
Right.
So,
but we could also like we're doing with the TLS cipher suites, like periodically go through the IANA registry and just import all the values we don't have and be like, yep, as part of the .NET 6 package, we added the 6 new tags that have been registered in the last year. And yeah, we don't know what they mean, but we totally told you that this is the name associated with that value.
For what it's worth, I haven't really included anything from the registry. These are just the values in the RFC.
Sure.
But it can be extended, obviously.
Sorry, I might have missed it because somebody had a MacBook issue. So do we have what does the extension look like? Like, do you expose the raw numeric value or the string, or what does that mean if you extend that set?
I presume you just define it as a constant, no?
Yeah, private const Seaboard tag thing from registry 5 equal 78. Well, you have to add a hard cast to it. But.
No, I guess I'm asking, like, how's this value, like, how's the tag surface? Is it just a numeric value to the consumer then?
Yeah.
I see. So that means if two people happen to decide that level 70 or that number 78 means something specific, then that's too bad. That's what the registry would be for.
Yeah.
Correct.
Gotcha. So do we want to go over the remaining ones, or do we just...
Yeah, sure. So, base 64 string later encoding, base 16 string later encoding, encoded Seaboard data item. So I believe that this denotes a raw byte string that is itself a Seaboard encoding. Again, no real bearing in what we're actually implementing. I've just added this. URI, as defined in RFC, blah, blah, blah. Base 64 URL, base 64. Can you scroll down, please? Regex, my message, and self-described Seaboard, which is basically just a magic value that you might optionally want to put at the top of your Seaboard document.
I don't understand why somebody would expose something as a regex. It makes no sense to me, but I mean, it's a string for all intents and purposes, right?
Yep.
At that point,
I mean,
it seems like first name, last name, and SSN would all be valid tags.
Right, but in ECMAScript, regex is a type that is distinct from string and has different serialization characteristics. So presumably this is just for interop with
JavaScript.
JSON.
I guess, yeah, that's fair.
Well, JSON doesn't have a regex type, so this is interop with just JavaScript right here.
Yeah, I was thinking of what, like, we don't expose a regex type either, right? So it's just a string, I guess. But yeah.
I mean, it's a nice thing for security reviews. Oh, no, someone is using regular expression. Let me beat them around the head with something heavy.
Yeah, I mean, all that it says in the spec is tag 35 is for regular expressions and Perl compatible regular expression / JavaScript syntax. Like,
literally copied and pasted from there in the example.
I'm sure that's what happened.
Right, and yeah, so all that tags are the I think the title of it was content hint. It's just a suggestion of this is the value that I'm wrapping. It's probably a regex. Interpret it like it is.
And they went with 55799 for what reason? It seems like a very arbitrary number.
Yeah, so that basically inserts a magic value at the beginning of a Seaboard document.
Oh, so that number is literally the magic value.
Basically. So that value is sort of the serialization of the tag. So it's more than 1 byte.
Fair enough. Seems fine with me. Unless anybody has any concerns with that, that seems like a reasonable set, considering
Okay.
that they're all spec listed values.
Yeah, like, I mean, personally, I would have called it self-describing Seaboard, but self-describe Seaboard is exactly what it says in the spec. So
Yeah, it actually used to be self-describing Seaboard, but then I changed that to match the spec.
so it's a spec word.
Yeah, so moving on, we have Seaboard simple value, which is, the one kind present in major type 7. There's also floating point numbers, which are confusingly not simple values. And simple values are, so a simple value is a byte-sized value. And, again, the spec defines 4 constants within that space: false, true, null, and undefined, which apparently will be used by certain decoders. Whenever there is a format error, it substitutes the bad value with undefined, which we don't do, but I've added it for completeness.
To go back to Seaboard tag, sorry to rewind. Emo, what are our current guidelines for ulong for an enum? Are we saying if this is shipping OOB, it should be CLS compliant, and so we should say long and negative numbers are a caller's problem, or what? We definitely need ulong because it's defined to be a 64-bit number. Or sorry, the longness. That's the space that the registry is occupying.
Yeah, I mean, I didn't even
it's
notice
the
it
use
too
the
long.
question.
I mean, I would probably go with long. Like, I have no idea what languages that are they don't, so, like, I don't know what VB does when you have a Seaboard tag, for example, like, because, I mean, normally, VB doesn't support unsigned data types. I mean, an enum is kind of behaving differently from a normal number type, so maybe it just works in VB, but unless there's a strong reason why it needs to be ulong, I would probably go with long. Because if it literally just bits on the wire, then it doesn't matter whether it's ulong or long.
So unsigned longs play a significant part in both the Seaboard spec and consequently in the public API in Seaboard Writer and Seaboard Reader. So, I would expect CLS compliance to be an issue here. Also, I would say that if we change this to long, that would certainly leave out certain hypothetical values over the maximum value of.
Well, just someone would have to define the const in terms of the negative representation of the same 64-bit value, which we've had happen in places, and it's unfortunate, but it's also pretty unlikely that they're going to actually get beyond bit 63.
Are these ever going to be used with shift arithmetic?
No.
They're not. The numbers aren't semantic. They're just essentially the order they were defined in. So no one should be mathing the tag. Yes, mathing, it's a verb.
I mean, generally speaking, I mean, if you math something and it's not a flags enum, you're doing it wrong anyways. But I think if it's an enum, I think ulong is just a weird choice.
Well, I was asking because there's various specs that sometimes define these individual values, and then they'll send it in a compressed form, in which case you might have to shift them together, in which case you don't want signed types because that messes up your arithmetic a lot of times.
That's fair. I mean, I'm just thinking, like, given that Seaboard value is a byte, we have plenty of byte-sized enums, and I don't think they are non-CLS compliant. So clearly VB must handle that, at least for byte-sized.
Well, byte and S-byte are reversed. Byte is unsigned, but it is the CLS compliant type, and S-byte is the non-CLS compliant one.
So telling me VB supports a byte, but it doesn't support S-byte. That's funny.
Right, because byte CLS compliant and S-byte is not.
Yeah, it supports the one that uses fewer letters.
Well, in that case. Yeah, maybe. I mean, it just seems odd to like restrict the negative thing. I mean, I understand that you need to hit the bit pattern, but as Jeremy said, I mean, you can encode the number in whatever form you want, right?
Right. So maybe we should take a note that says that might need to switch to long, but I think it'll depend on if we feel that this whole thing is.
That will be pervasive in the upcoming APIs because ulong plays a significant issue in many places.
Right, but in some cases it may be that it can be solved with overloading, but this one is. I guess one question here, because I certainly don't know, is how does VB react to ulong backed enums? Like, did we just drop that language completely out versus some things are harder to use?
Yeah. I mean, in fairness, like I've always find it weird that we have so much trouble with unsigned types, but then we tell people like, by all means, you have to support generics, which is several orders of magnitude harder to support or overloading on like a million types.
So why doesn't VB support ulong? I'm looking at the language guide right here, and it indicates it supports it.
My understanding is VB has no support for unsigned data types.
Dim ulong value as ulong.
Well,
Right.
but is that actually just defining it in terms? Like, is there a keyword effectively? Is my question. Like, is there
Yes.
language support? Okay, then I don't understand it. maybe it's a non-issue.
Don't know much about VB, but my understanding is that it had been fixed at some point. Support for unsigned types.
Maybe they added that. Maybe yeah. I mean,
may-
I'm not following.
Maybe I'm
VB.
wrong, but
Yeah.
I kind of assumed that CLS compliance was, irrelevant at this point. But
I don't think we can have that conversation on a recorded call. It's controversial. Right. I mean, I do know that for COM, assuming that I'm remembering correctly, COM essentially just talks about the number of bits in the value, and so it's just like this is a 64-bit number, and so COM assumes signed except for the 8-bit, which is unsigned. So that definitely would come from like a middle definition, but I mean, we certainly don't care about COM interop here.
Yeah. Let's just take a note and move on, given that we have 45 minutes left, and we haven't really past scrolled the first enums yet.
Yep.
Yeah, I mean,
Does anybody-
for the simple value, I know that I had some byte-backed enums in ASN Reader that we changed to int. So unless this is being inline packed somewhere, if it's just a return type, then I think based on what we did to ASN, we would remove the restriction here.
Well, simple values live in the byte space, so we would have to reject values over 255. So.
And you're accepting it as an input somewhere.
Exactly. Yeah.
Okay.
And the same applies to Seaboard Tag, I should say.
Okay, because I think mine was mine was a return value only, and only 4 values were legal. So, byte was even way too big. But
Having been an avid reader of the daily WTF, I'm disappointed that it doesn't have file not found.
Sorry.
a simple value of file not found.
Yeah, there was this internet site, I think it still exists, the daily WTF, and they always showcase stupid enterprise code where people over-engineer stuff, and somebody defined a boolean, and the boolean had 3 values: false, true, and file not found.
Yeah.
So that's
Nullable
why.
booleans.
Exactly. All right, so then Seaboard Writer.
Okay, so let's start with a constructor. The Seaboard Writer exposes a single constructor accepting 3 parameters. All are optional. So obviously the conformance level, as discussed, the default currently is lax. It additionally exposes a couple other Boolean parameters. The first one is convert indefinite length encodings, which is, as I mentioned before, this mode where the writer will convert indefinite length encodings into definite length equivalents for optimized reads, and also for conformance level reasons. The default here is false, so users will have to opt in for this behavior. Then the other parameter is allow multiple root level values, which, as you would expect, lets you write multiple root level Seaboard values with a single Seaboard writer. Again, that the default here is false, and it can throw one type of exception whenever the conformance level is not recognized. I think that covers the constructor. Are there any questions regarding that?
I will say that the guidance that we gave for default parameters is once you have more than 2 of them, you should have an overload that removes all the default parameters. Just for IntelliSense niceness.
Okay.
I mean, my question is also like, because it seems like potentially becoming a grab bag of stuff, like the more and more options you have, eventually you're better off with just a dedicated options type. But if you only have 3, then it's fine. Given the spec is already done and you have implemented the spec, it doesn't seem like there's potential for a lot of more options, but it's
I mean, it is
consider.
conceivable that, new things might prop up. So, I kind of avoided the configuration class just to avoid over-engineering in this case. It just didn't feel convincing enough at this point, but I can add it.
Yeah, I mean, it's a trade-off, right? I mean, if you have, like, I mean, it doesn't have to be perfect, right? But if you're fairly confident, very unlikely to add in the very near future more values to the constructor, then I think it's fine. Like, if you eventually have to add one, it's also not a biggie, right? We can, worst case, we add a third parameter, and if that doesn't fly, then we can still do the options type.
Yeah.
But
Yeah, and while I did bring up the guidance for default, I believe that this is going to be a advanced enough API that it maybe wouldn't need the simplified constructor. So it's definitely a consider and a take note. But
I would also say it's kind of
like
like
this is on string.
It's kind of like also what do you expect, right? I mean, like the problem is also when you have defaults for primitive types that are booleans, it's probably fine. If you ask me for like fairly complicated types like an interface or some other stuff where I have no idea where I would get a value from, then that's more of a problem.
Yeah, and I guess one point where there was the discussion of what should a default be for the conformance level is that maybe the conformance level is not a defaulted parameter, and we just make people specify it as the last required parameter. We could change that later. We can add a default, and that wouldn't break any existing code. So that is just one thing to consider. If we can't decide on what the default should be, maybe that means there shouldn't be one.
Right. I mean, it's generally nice if you can construct types without passing anything in, but yeah, I can see that argument. What does XML do? Do we default or do we make people choose?
I don't know. I know for ASN, it's people have to choose because dir is probably what the reader expects. Bur is the most forgiving, and sir is not used by anybody, but I wrote it anyway.
I guess for the reader, probably Lex makes more sense because it means you can read anything. For the writer, I mean, you can write anything if you want, but like, doesn't mean that the person that receives the payload can read what you just wrote, right? So like, it seems.
Well, I should probably note that 80% of canonical mode conformance on the writer side is observed even with lax conformance. Just because we're not doing crazy things with the stuff that we're serializing. What is being added from the writer's perspective is that it does the extra work of, keeping track of whether there are duplicate keys in a map or whether the keys are sorted, which arguably could have been tracked by the user code that uses the writer.
Right. Yeah, I don't have strong feelings here. Like, if you make people choose, that seems fine. If you make them not choose, that seems also fine. It seems like unless we put in C-tab too, like Barry will have to choose anyway.
Yeah, and then so what would the difference of the writer's mode being in lax be from canonical? That someone could observe.
So basically, it's validating UTF-8. and validating uniqueness of keys in maps, and in canonical mode, sortedness as well. These are sort of the differences from the writer side.
Where canonical will do the sorting and lax will just take it in the order it was presented.
Correct. Yeah. So basically, I probably didn't mention this, but the Seaboard writer will auto sort the keys as they are written, primarily because the sorting is done on the encoding level, and as such, the user cannot reasonably, sequence the operations in a way that conforms without being intimately familiar with, the internals of Seaboard in the first place, if that makes sense.
Sounds like no one has a strong opinion.
Okay.
Yeah, so I would say just have the note of consider whether if after we're all done with this, if you feel that there was enough controversy that means that it should be a non-defaulted parameter, then that would be a change to make here.
Yep. Okay, are we okay with the constructor then? Should we move on?
Yep. Constructor seems
Okay.
fine.
And I guess before we get there, I'll just ask now. So if I say I'm in canonical, which prohibits indefinite length encodings, does that mean that convert is always true, or that the indefinite things when we get to them will throw?
Good question. So unless you have opted into that behavior, any accessing indefinite length APIs will result in an invalid operation exception.
Okay. And so the default you've gone with here is the performant default instead of the make everything work default.
Correct. Like I said, I don't really have a strong opinion here. I just went for the thing that needs the less work for the purposes of this review.
Mm-hmm. Right. I'll say I would encourage it to be true for convert indefinite length encodings, which is make the API do more work, and then someone gets to opt into I want you to do less tracking and less reallocation, but that's me. So I would go for friendly defaults and performant options instead of the performant default.
Okay.
All right, so then I guess pass the constructor then.
Yep.
Allow
Okay,
multiple
so
root level values.
yeah, so the following three properties basically just echo the constructor parameters.
Oh yeah.
And then we have three properties that refer to the current state of the writer. So you have bytes written, as you would expect, just returns the number of bytes that have been written to the buffer. The current depth, again, returns the level of nestedness in the current Seaboard document. And the isWrite completed property basically returns true if the writer has completed writing of a full well-formed Seaboard document or sequence of well-formed root level Seaboard documents, depending on the configuration. Now, the reason why I've exposed this in public is that this property is actually checked when you're trying to get the encoding. If it's not satisfied, you will get an invalid operation exception.
Right. So it's just if it returns false, that's just telling you the encode methods are going to throw.
Yeah.
And so it's just letting you, if you were stepping through in a debugger, tracking when did it flip from true back to false and what went wrong.
Mm-hmm. Okay, should I go ahead? And then we have the get encoding values. So the first one, the encode method, just returns a new array that contains the encoded value. It's just copies the data from the buffer into a new array that it allocates. And there's also the try encode, which is a non-allocating equivalent that just writes the data to a span provided by the caller and will return false if and only if the destination isn't large enough for the buffer.
And I can call encode multiple times, right?
I believe, yeah. I would need to double check, but unless there's a bug, it should be capable of doing that.
So there's basically no side effect. It doesn't reset the writer or
no, it
free buffer or
shouldn't have
anything like that. Okay.
any side effects. If you actually wanted to reset and reuse your writer, you just call the reset method, which is right below, which behaves as you would expect.
And try encode is also throwing the invalid operation exception of it's not in a write complete state.
Mm-hmm.
Okay.
Yep.
Would there be any benefit to taking a iBuffer writer instead of returning a new array?
I'm not sure, to be honest. I just emulated the ASN writer API, to be honest. I just found this to be sort of the simplest entry point in this case.
Yeah, I mean, I don't think we've taken iBuffer writer anywhere.
Okay.
I also don't know. I don't know off the top of my head what our target is for this package, and then I don't know what targets iBuffer writer has either. So whether this is net 5 or net standard 2 or what.
So Kevin is asking, would it be meaningful to expose an API that gets the encoded length without performing the encode? Would it be cheap to implement? That might help folks get the right.
Emo, you've gone Dalek mode.
Sorry, what?
Your audio is very distorted.
There's not much I can do, I guess. Normally gets better eventually.
But I think the answer to Kevin's question, since I can see it, is at the top of what's being presented right now, there's the property bytes written that tells you how long the output to encode would be and what the minimum length to try encode would be.
Correct, yeah.
So you don't have to do the double and retry loop. The writer tells you how big the output currently will be after every operation because it's a property. So it'll give you the incomplete progress, Eric?
Yep.
Yeah.
Okay, so are there any questions regarding this particular set of methods? Okay, should we just go ahead then?
Yeah, I will say one thing that I missed in ASN writer is adding an encode that writes to a span. So the span writing encode that is just encode returning an int of the I promise it's big enough, just write to my span, because then that eliminates the needing to deal with the false case. So it would just throw if the span's too short. In most of the cases that I wanted to use it, I've already called what's the length that I need to make sure my buffer is big enough, and it just makes for essentially a dead block that I have to deal with.
Yep.
So I would recommend adding public int encode span of byte destination, and so that'll throw an argument exception if destination is smaller than bytes written.
Right.
So can you repeat the signature?
Public int encode of span of byte destination. And then I should probably put up a proposal to add that to ASN writer.
And so the idea here is that if the buffer isn't large enough, it tells you how much it needs?
No, it throws a argument exception that you should have checked bytes written before calling this method. Because the type is already exposing this is the minimum length that you need to pass to make try encode succeed. If you've already checked it, you can avoid the redundant try and dealing with the false. I mean, there would be no false, but now you have the do you call a try method and ignore the return value, which makes Levi cry, or do you have this if not throw unreachable code exception?
Gotcha.
Yeah, I mean, realistically speaking, I wouldn't think of a valid use case where you would do something useful in if try and code returns false in the first place.
The common place you would do it is if you just had nested encodings and you're just hoping that your buffer is already big enough, then it returns false, and now you need to do the reallocate. It's the same as checking bytes written ahead of time, but it can make your code look cleaner depending on how much other stuff you have going on.
Okay.
It's all about composition instead of direct usage.
Yeah.
Check out
and bytes
Chapter
written,
9, Section 11 in Framework Design Guidelines V3 for more information.
and so bytes written is literally the total size of the buffer I would need to have.
Basically, yeah.
It would be that would be the same as the value returned by encode or written to bytes written in try encode.
Yep.
Gotcha. And I guess reset just basically nukes the data, but it keeps the memory allocated.
Yeah, correct. Including certain pooled allocations that are being used for tracking conformance.
So that means after call reset, I can basically treat the type as the same way as I would when I would have recreated the type from scratch.
Correct, yeah. So you won't be able to change the conformance level, for example, but you would be able to write a new value.
Sweet. So that means somebody could pool these types if they wanted to.
Right. Yeah, following the guidance of having ASN writer not be disposable and using the array pool, Eric made the same changes here, and so it's the same. You get to use whatever the peak allocated buffer was instead of doing realloc grows over and over again.
Okay, I guess I should move on then. So let's talk about, so I've sorted the write methods by major type. So I'm going to start with major types 0 and 1, which reminder is unsigned integers and negative integers respectively. So for supporting writes for these particular major types, I've exposed this set of methods. So to begin, we're looking at signed integer encodings, which can end up being either major type 0 or major type 1, depending on the sign of the values. So there's nothing really controversial here. It just write int32 accepts an int value and performs the write, but it can throw an invalid operation exception depending on certain situations. So one example is that you're trying, for example, to write that value into an invalid context, for example, an indefinite length string, or whether it is a duplicate key in a map with canonical conformance, or what's the third one?
Fifth item in a 4-item array.
Exactly, yeah, that's the one, and that is basically a recurring pattern for all the write methods. So I've added those here, and we'll have omitted those in other methods. Similarly for int64, then you have a similar set for unsigned integer encoding, so 32-bit and 64-bit, behave as you would expect. And finally, probably the most interesting method in this set is the intentionally long method name called write seaboard negative integer encoding. And this is a method intended as an escape hatch for certain situations where you might need to encode a particularly large negative integer that falls outside of the range of standard long. So it doesn't have a natural representation in the native integer values. And the argument that it is accepting is a ulong, and that ulong is basically the internal Seaboard implementation for negative values. So I guess the takeaway here is that people calling this method need to be intimately familiar with Seaboard and should know when to use it. Does that make sense?
It does. Also seems fine naming wise.
Okay.
Since ignoring the negative integer encoding one, since all 4 of these methods are, I guess, 2 of them are always writing 0, and then the other 2 are writing 0 or 1 is dependent on the value. Would it make more sense for these just to be write integer with 4 overloads?
Is there a precedent for that convention?
So I was looking to see which way I'd actually gone in ASN Writer. It's in ASN Writer, the concept you're writing is an integer, no matter what the value is, and it has the same semantics of a small number takes fewer bytes than a bigger number in the encoding. And so I just have write integer.
But doesn't that break the symmetry with the read methods, though?
It does, because well, I mean, I do also have read integer, which gives the raw encoding, or actually, I guess it gave a big int. But there's, try read int 32, where the type has to be in it now because it's implying restriction. So it is a little bit asymmetric, but it's yeah. So that's a thing we've done elsewhere. I'll let other people say whether they think collapsing or violating symmetry or maintaining symmetry is better.
I mean, text writer is a canonical example, right? You only have write methods and write line methods, and they're overloaded with like a million things. And it's both good and bad. It's good when it's convenient. It's really bad when you need to write an actual file format. So for text reader and text writer, I never really cared. Because even if you pick the wrong overload, the output is text, which doesn't really matter. But for binary reader and binary writer, for example, I found the generic write method on binary writer to be utterly unhelpful because I very often forgot that I had to cast my whatever it is, to a short or a byte to get the correct encoding. And I would have spotted this much easier if I would have actually called a method called, write byte or write in 32 or write in 16. And yeah, it bugs me always that there is no symmetry between reader and writer, but I guess there's enough prior art for generic overloaded write methods that fighting this now seems kind of backwards as well. But I will say that it has annoyed me multiple times.
Yeah, I don't think that we would want to go so far as to have everything just be write, with just solid overloading. But write int 32, like if you call write int 64 and give it the up converted long of an int 32, it's going to produce the same output as if you called write int 32. It's not going to write it as a 64-bit encoded value in the output because the encoding rules say you shrink it down to the fewest number of bytes that you needed. So that's the only reason that I'm encouraging or asking if overloading is the correct answer.
So it is basically like text writer, right? Where it really doesn't matter which one you pick, so long the textual representation is the same. In which case, I would agree that overloading
for
sense.
For these 4 methods. I mean, certainly they're going to write down a different thing if you give it false.
Right.
But for these, if you have the number, the literal 1, and you pass it to all 4 of these things, it will give identical output in the when you call encode.
Yeah, that seems fine. I mean,
I'm looking to see what we did for JSON.
I mean, you never have 100% symmetry with reader and writer anyway, because of the way the data flows usually. So, as long as people can understand what to call, it's fine in my opinion. So having just, write integer and then have corresponding read methods. I mean, the question is how you would call the read methods, but you can always go with, write integer 32, write integer 64, right, if you really have to.
For JSON, we said all the numeric types because they end up just as the JSON concept of number. In the writer, they were all overloads to write number, and then the reader, because it's returning a value and you can't overload by return type, they all then were get and then the data type you were looking for.
Gotcha.
So
I think that's fair.
In JSON, we did the writer collapsed based on the spec concept, and the reader had to expand to accommodate the type system. So we went with asymmetry with overloading. That said, in the chat, Kevin says he prefers explicit write int 32 and write int 64, but I don't know if he assumed that they were presenting different encodings.
I mean, we would have to make a departure from naming convention just for integer types. For everything else, we'd still have to explicitly pin down the individual types. So you actually have write big integer and then write integer.
Right.
Yeah.
Right, because big integer does use a different encoding than integer.
Yep.
So yeah, maybe that's enough of a reason to say write the thing that you think that you have, and it understands internally when they collapse and when they don't. But
Yeah.
I just wanted to raise the issue for discussion.
Yeah, to me, the question really is like, what does the rest of the API look like? I mean, I can live with what you currently have on screen. If we can get to the point where the JSON one was, where we just say here's like 4 spec models or 4 spec concepts, and then we just have basically 4 methods corresponding to the spec things, and then everything else is just overloaded based on, there's many .NET types that map to the same spec concept, then that's, I think, fine. If that's not doable because you already had to explode it anyways, then you might as well be consistent with the rest and just always say, write and then whatever the .NET data type is. Except for C1 negative integer encoding because, well, it's special.
Okay.
All right, then let's go with the next one, Seaboard Writer.
Mm-hmm. So, byte strings. So I'm just going to repeat what's written here. So the Seaboard spec, to recap, permits 2 types of byte strings, definite length and indefinite length. And indefinite length strings are basically defined as a sequence of definite length strings. So they're just essentially arrays containing definite length chunks. So the API experience here is pretty much, like an array in the sense that you're pushing a indefinite length byte string context, then you're writing your byte string chunks and then popping the context. So going through the individual methods here, there is the write byte string method, which accepts a read-only span of byte as you would expect and behaves much in the same way as the previous write methods you saw, and that will explicitly write this as a definite length encoding. And then you have the write start byte string, which explicitly pushes an indefinite length byte string encoding. And similarly, you have the write end byte string, which pops that context. I have kept some remarks here. Basically, if you try to call the write start byte string method, it will throw an invalid operation exception unless you have opted into this behavior that lets the writer patch the encoding back into an equivalent definite length encoding. And yeah.
So when you say write start byte string, so what can I write afterwards?
When calling write byte string.
So after I called write start byte string, what can I call afterwards?
You can call a sequence of write byte string methods. And if you try to call anything else, if you tried, for example, to write a text string, or if you try to write an integer, it would throw an invalid operation exception. So it's basically, a strongly typed byte string array. I think that's the way I think of it.
I see. So that means write byte string can either be called by itself, in which case it will be length prefixed, or after I call write start byte string, in which case basically multiple calls will be effectively concatenated.
Yeah.
And then
they will be concatenated provided that you've opted into this patching mechanism. If you didn't use that, which is the default, it will basically, what it looks like in the Seaboard encoding, it would write an initial byte saying that, the next thing coming up is a byte string with indefinite length, and then you would have a sequence of definite length byte strings. But they must be definite length. You cannot nest indefinite length byte strings, if that makes sense. If you try to call write byte string twice, namely, the second time will throw.
Write start byte string.
Write start byte string, yeah.
I see. So write byte, so there's no nesting effectively.
Correct.
It's basically just a flat list of buffers.
Exactly, yeah.
Yeah.
Okay, that makes sense. I mean,
I don't have a single use case for that, but the Seaboard spec permits it, so I implemented it.
Right, that makes sense too. Yeah. I mean, I can see it being convenient for the writer for sure.
Yeah.
Yeah. Does anybody have any concerns with that? Because that looks good otherwise.
I might have one point to make here. The naming of the methods intentionally follows Seaboard naming conventions rather than .NET naming conventions. Like this could have been write byte array, for instance, but
Right.
didn't go with that.
Well, I mean, again, this goes back to like what makes sense, right? I mean, I will say that first time I saw write byte string, it threw me off, but then I kind of assumed that it's basically just a fancy word for saying byte array.
Yeah.
I mean, if you just say write bytes, but then it's also like write start bytes is also very weird.
Yeah.
I'm making the assumption that people using this API are familiar with the basic concept of Seaboard, so
Right.
they will know what this means.
I mean, it's
Yeah,
kind of like
and
XML,
for
right? Like XML also has the notion of an attribute, and we don't say, oh, it's a .NET attribute, right? It's the XML notion of an attribute.
Yeah, in Seaboard they're called byte string and text string. In ASN they're called octet string and character string. And because in ASN, yeah, we went with the words that the spec said.
Yep.
All right.
Yeah. So UTF-8 strings, major type 3, essentially the same design. For definite length text strings, it accepts a read-only span of char, and it can throw an argument exception depending on your conformance level. If it is anything other than lax, then if it's not a valid UTF-8 string, it will throw. Indefinite length text strings work in much the same way as indefinite length byte strings.
So you say UTF-8, but you only accept UTF-16. That's a bit weird.
Yep.
UTF-8's the wire encoding.
Yep.
It takes text.
Yeah, I get that, but I mean, like, given that we have representation for UTF-8, it seems odd that you don't accept it.
Which representation are you referring to?
Well, we don't only span of byte. It's the only one we have right now.
Right. I mean, we could consider that as an overload. I think we're waiting on just UTF-8 string to land so we can unify on that and not propagate ROS byte.
Right. It also
Should we
seems
add-
weird that you don't have overload for string. Like, that seems also something we probably want.
For F#, you mean?
Yeah, for write text string.
Yeah. I mean, it's just going to null check and then call the span one, but it's yeah. I think we have generally said anywhere that we take read-only span of char, it makes sense to overload it taking system string.
Yeah, it doesn't buy C# anything, but it buys any other language that doesn't support spans or implicit conversions.
For what it's worth, I think F# are working on tolerating implicit conversions for some of those things, which are becoming pervasive. So it might actually be solved on the language level. Maybe not soon, but.
Yeah, I mean, because this hits the question of familiarity. Like, this is low level, so maybe someone's expected to work with span, but again, just for the closest comparison in namespace and time, for ASN, I did if it took read-only span of char, I overloaded it with string, but I didn't do byte arrays as overloads for read-only span of byte.
You monster.
Yeah.
I mean,
I'm only half nice.
My general argument for these kind of things is like the overloads don't cost us much, but potentially they just make it easier for consumption languages that don't have support for that. And even if F# does it, like the long tail of languages is longer than we want to admit. And I don't know whether we want to.
COBOL.NET.
I mean, yeah, I mean, these things are, they do exist, right? They're real. Like, I mean, I'm not sure how many of them are supporting core yet, if any, but.
I think COBOL.NET does.
COBOL.NET Core?
Yeah, I feel like when we were having a conversation about this like a year ago, I looked it up and they had just added support for core.
Yeah. Yeah, other than that, looks good. Like, I don't feel strongly in UTF-8. Like, it just seems odd to not support it. But if you just wait for UTF-8 string, that's fine.
Yeah, I suppose that once it is added, we can add support for that.
Yeah.
Should be no issue. Cool. So arrays. So again, to recap, array data items can be thought of as JSON arrays. The Seaboard array can contain data items of any major type and can be either definite or indefinite length. So again, there are two write start array overloads, one for definite length writing, where you actually just declare the length as an argument. And likewise, you have the indefinite length variant, which doesn't accept any argument. And then both kinds are concluded by calling the write end array method. Again, as before, the indefinite length version of write start array will throw an invalid operation exception if the conformance level does not support them, and also there is no patching opted in the writer.
But those can be nested, correct?
Yes, they can be nested arbitrarily.
Right. So I will say that if we want to keep the default for convert indefinite length encodings as false, that I would recommend collapsing these overloads into a nullable int. So someone has to make the indefinite be explicit, but that it would be that the easy to use API of you call the write start array and I don't know the length, like the 0 parameter one, the fact that that will fail in modes that we think are going to be common modes for the writer suggests that there's a mismatch in API parity.
Sorry, I'm not sure I follow your argument. Are you basically saying that by making it a nullable int, we make it a bit more obvious on the call side what happens?
We make someone, like, right now, so if you call write start array paren, and you called the constructor in the form that it was proposed and said, and my conformance level is canonical, then write start array paren will throw, write start array int will not.
I see.
And
you're basically saying the simple one should work.
Right, that the simple one should work, or should be more likely to work than the complicated one.
I think I buy that, especially because we already have on the reader side, we already said we exposed the definite length as null anyway. It seems logical to accept a nullable int.
Yeah.
And yeah, so it means if you are using the patching mode, that you call write start array null, but I'm also completely fine with keeping write start array paren if we switch the default of convert indefinite length encodings to be true, because then you're opting into code you may have already written will now start failing.
I like the nullable approach because it makes it more explicit which one you want. You're less likely to use the wrong one.
Okay.
Mm-hmm.
Yeah, I agree with that. I mean, even if you switch to default, it doesn't change the fact that the simpler overload now has still more potential for failure, right? It just means that you just opted into that failure, but like it still works in fewer cases.
So one approach we went for initially was to use a much longer name for the indefinite length variant, something, write start array indefinite length with that kind of suffix, just to make it both to discourage users from calling that particular variant and to sort of clearly distinguish the two. But, in the end, I just removed that.
Yeah, I mean, if you make it a suffix of write start array, I think it would work. But then I have no idea how common that is. If it's still a fairly common encoding in some cases, like it might be very annoying. But I mean, to me, null would seem sufficient because anybody who has .NET development done for more than a week knows that null is a magic value. So you kind of start to wonder what that means when you pass a null for that.
Personally, I'd be in favor in making it accept a nullable parameter rather than changing the default, to be honest, because it just has an implicit cost. Like it's you pay a linear time penalty every time you need to patch something.
Yeah. I also like Corey's argument of it means the writer takes what the reader returned.
Yeah.
So you can call write start array. If you're doing a drain one into the other, you call write start array of reader.read start array, and it turns indefinite into indefinite and definite into definite. Yeah, that's hard to say.
Definitely.
So, all right. So collapse the two overloads into one, taking a nullable int.
By the way, I should point out that nullable parameters also interrupt very poorly with F#. But likewise, they're working on allowing implicit conversions in that domain as well.
Yeah. That's a problem in and of itself. Maps.
Maps. Okay, so maps are the equivalent of a JSON object. Again, arbitrary nestedness. Main difference is that keys can be of any major type, and key value key value pairs are written in sequence, and it is the responsibility of the caller to track whether the next value is a key or a value. And again, maps can contain either definite or indefinite length key value pair counts. Again, similar story with the methods. Write start map. Again, same shape here. Obviously, if we go for the recommendation in array, we'll do the same thing with map. And write end map for ending the context either for definite or indefinite length maps. I've added a note here, which I don't remember. So yeah, it might actually throw an invalid operation exception if you've for example, written a key that is not accompanied by a value. Again, this is a side effect of the fact that callers need to keep track on what the next value is going to be.
Right. Seems fine to me, and the only change I would make is the same as before. We should probably collapse the write start map overloads into one that takes a nullable int, but other than that, seems
cool.
Reasonable.
So Emo.
Here's one.
As a caller of this API, if you were writing 5 key value pairs, what value do you think that you have to pass to write start map to make that write in a definite length? 5 or 10?
Oh, yeah, I would definitely expect to be 5, because I would say that's the number of elements in the dictionary, right? I would not expect to have to push 10.
Okay, so the question there was to ask, was definite length, was it obvious to you that it mapped to the number of key value pairs as opposed to the number of total values, or sorry, total items? Or did it need to say key count or anything more complicated?
Size.
So if we think it's like that is the correct answer, so if that was the obvious interpretation, then we're good.
I mean, I say that, right? But then I think when I'm actually starting the calls, I would probably say, maybe I should double the number now. So the question is, do I do this before I'm running it or after? But
right.
Because I mean, yeah, it is a bit weird when you say, you say write start and then you say write, and you're like, there's more write calls that I said I will have to do. But I guess, I mean, if you would have to rename the parameter in something that indicates that it's pairs, but I'm not sure what naming you would have that would still be somewhat sane.
Right. Yeah, I can. I have enough knowledge to ask the question of, is the name suggestive enough? I don't have a good suggestion of what a better name might be.
I mean, definite number of pairs would be not too bad, but it's very long.
I kind of agree that definite length in this context is misleading, and maybe count or size might be more appropriate.
Honestly, to me, count, size, and length are all the same problem because it doesn't indicate to me what you're counting, because there is a cognitive dissonance here, right? That you're basically asking people like, I'm starting a map, but then you make them write the individual things, and so depending on how the person sees that, I can see that being confusing.
Yeah.
Because your programming model is not pairs. Your programming model is atomic building blocks, right? And so unless you say you give me the number of pairs, I don't know how people would avoid that. But at the end of the day, like, there's only one correct answer, and your code will never work, right? So in that sense,
Right.
you will find out very quickly.
Yes, it is. You write it once, you find your bug, you fix it. The chat suggested key value pair length. I was going to say key value pair count is probably better, and then the chat also suggested key value pair count.
I mean, it seems you still want to include the word definite, though, right?
Maybe like that is a question, because once it's nullable int, null is indefinite, and then the int half is the definite half. So maybe definite stays, but those are some things to think about. I don't know that we can pick a good name in
For
the
what
negative
it's
5
worth,
minutes we have.
Strictly following the Seaboard spec, the definite length is precisely that. So, assuming a person is familiar with Seaboard, there will be no ambiguity. Okay.
Are we close enough to the end here, Eric, that it's worth pushing through for the writer before calling it a day?
Yeah, there's two
Since
more
we are
groups. So there's this one here, and then there's this one, and then we are done with the writer, and then I would call it a day.
Okay.
And then do
Up
the
to
reader.
you.
I think it would be good
That
to finish
seems-
the writer.
Okay.
Yeah, that seems short enough.
Okay, so I'm going to do this quickly. Major type 6, again, is Seaboard Tags. So basically just, so that's broken up into two pieces. One, just basic support for writing tags. And secondly, just implementing semantic tags as described in the Seaboard spec for some of the types that exist in .NET. So the first method is write tag, which accepts the Seaboard tag enum, which we discussed previously. That's the unsigned long enumeration. Again, precisely same semantics as the previous write methods. And then we have the individual semantic tag implementations. There's a write datetime offset, which accepts a datetime offset value, and that serializes it into a tagged datetime string following RFC 3339, if I'm not mistaken. I might be wrong. I'm trying to remember it, but it's basically that ISO datetime thing.
TM.
And all of these methods throw invalid operation exception in CTAP2 canonical, right?
Correct, because CTAP2 canonical does not allow any form of tagging. So basically, major type 6 is outlawed outright.
So I'm still somewhat confused. So basically, when I say write datetime offset, you're basically writing both a tag and the encoded value?
Yeah, so it's basically a tag that nests a string encoding of that datetime offset.
So when would I call write tag then?
That would be done by the method itself. That would write the tag for you.
But
if you wanted to support tag 78 and the writer didn't support it directly.
Yeah.
So so then I call write tag, but then what do I do to write the raw value?
So basically, if you were to implement write datetime offset yourself, you would be making two calls. One for writing the relevant tag of datetime offset, which is 0, and then writing a text string that contains the string rendering of that datetime offset value.
Oh, I see. Okay. Because I was assuming that I can write value or something, but that makes sense.
Tags wrap precisely one value.
You can think of all these methods as essentially extension methods. You can't really express them as extension methods here because of rollback semantics, but they're essentially extension methods building on top of the Seaboard writer building blocks.
Gotcha. So then, can anybody actually do that then if you can't make them extension methods? Like, should we make write tag private, basically?
Pardon?
Like, should we, because basically you said, like, people can't, I mean, you can think of write datetime offset as an extension method, but then you said people can't really do that because of rollback semantics. So basically my question is, should we make write tag a private method if people can't actually use it reliably?
Well, they can, but the only problem is that, if you're implementing a method that does a bunch of writes and one of them throw, then Seaboard doesn't expose a public mechanism that lets you say, oh, I actually want to return, I want to rewind all the writes that happened before I actually initialize this method of mine. We were kind of debating whether the checkpointing logic should be exposed, but we decided against that.
Yeah, I mean, the question here really, it just boils down to, because the only thing that could really go wrong from write datetime offset if you implemented it yourself is if you oomed during the realloc of when you called write string, that we would leave the tag written in the buffer. So the call to write tag succeeded, but then the only rolls back or only fails to commit the write string call, versus if you call write datetime offset directly on it and we then neither the tag nor the value got written because the caller didn't see a public method succeed.
Yeah, that's a good point. Actually, that actually is more relevant on the reader side of things, where more things can go wrong. So I wouldn't say it's realistically an issue on the writer side.
If someone writing these as an extension method did validation ahead of time, but none of these have invalid input values, the only thing that goes wrong is and it's do we leak the fact that the write tag succeeded. So it's not, while there is technically an observable difference, it's within the boundary conditions of what we consider observable.
Yeah, makes sense. I mean, as long as we think that makes sense, I guess I'm fine with that. I'm not sure that rollback semantics are. Some people can actually reason about that, I guess. I would generally assume the instance is dead at that point, but
I think for me the main priority here was ensuring that all the methods that we expose are exception safe.
Right. Anybody else any feedback on these APIs?
Should I keep enumerating them?
Oh, sorry. I thought we already scanned them all, but I guess No, go ahead.
Yeah. I think there might be one thing worth discussing here. So I'm exposing two write Unix time seconds methods. One that accepts a long representation and another one accepting a floating point representation. The reason why I do this is that the Seaboard spec obviously permits both. So I just have the methods accept those. Also, I intentionally made the methods not accept any kind of datetime values because when you're reasoning in epochs, numeric values should suffice.
Right.
Yeah, and datetime offset has to Unix time seconds exposed on it. So
what does it return?
It's just
long.
Either long or int, probably long because I think we've already rolled past the 30-second bit day.
It's long. It's long for datetime offset.
Makes sense.
Right. So write big integer for big integer and write decimal as you would expect for decimals.
Yeah, and then just to be make sure that everybody else has the clarity, when we talked about the major type 0 and 1 integers and big integer, they are different encodings. This is saying write big integer and using the number 1 and catching the implicit conversion to big integer does produce a different byte output than calling write int 32 of 1.
Yeah.
Cool. I don't hear any other person yelling, so I'll scroll.
Okay.
Right file not found. Yeah, so they're all overloads, basically just forwarding to write simple value, I suppose, right?
Did you scroll down? Because I'm still seeing major type 6.
I did.
He scrolled one of his two browser windows.
No, I scrolled the right one. Definitely, I see it in the right one. Let me unshare my screen and reshare my screen because
What's funny is YouTube got the scroll and Teams didn't.
What?
yeah, my Teams thing is weird. You guys can still hear me, right?
Yep. I might actually just look it up myself.
I can't share my screen anymore. I think Teams is hanging. No matter where.
Okay,
I click.
so can YouTube see major type 7?
Yeah, YouTube just gets the screen share, so that's a different thing than the window share I do for Teams. But
should I just go ahead then?
Yeah, YouTube currently sees simple and floating point values major type 7 through the param ref of right encoded value.
Okay. So again, a recap from the introduction. Major type 7 actually encodes two different kinds of values. So you have simple values, which are basically byte-size numbers used for denoting stuff like false and null, etc. And then you have floating point encodings in either half, single, or double precision. So for as far as simple values are concerned, the basic method here is write simple value, which accepts the Seaboard simple value enum, which is backed by byte. Again, it has the behavior as you would expect from their previous methods. And then there are a couple of helper methods for the simple values that have already been defined in the spec. So write Boolean for bool, and write null for just writing a null value, which returns void. I guess I'll take a break here so that we cover any questions for simple values.
I think you just said it, right? They all just forward to write simple value, right? Because they all just...
Yeah. Okay,
Well,
so...
Oh, yeah, you didn't say single or double yet.
Yeah.
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 So yeah, single and double are of major type 7, but are not single values,
right.
Simple values. So there's a float overload and a double overload. As you might notice, there is no write method for half precision encodings because there's no half primitive, but I'm assuming we'll get one eventually.
Yeah, we just more or less approved the API shape for half, so depending on when it goes out. I mean, I'm not sure how popular half is in general, but...
Right. And does it... You're going to blit these values the exact way they're represented, right? You're not going to do the... You wrote the number 2, and therefore we could have written that as a half?
So that's a good question. Certain implementations, including the reference implementation, do that. So, like for example, if you were to write a nan, certain implementations might bring that down to half precision, or if the value is an integer. But this implementation doesn't do that. First of all, because we don't have a half primitive, so we will only be doing this halfway through. Like we could only do it down to single precision. And secondly, another reason is that CTAP2 explicitly prohibits this kind of conversion. So whatever you write, it will have to be explicitly be transferred to the binary layer.
Yeah, that seems fine to me.
Once we get a half primitive, we could conceivably make this optimization provided that users opt in, but we don't do that at this point.
Yeah, do you... What is the intended TFM for this package?
Currently, well, I mean, if we were to, I'm assuming that it should work with Net Standard 2.1. I'm not sure. So I don't believe it would work for Net Standard 2.0 out of the box because it is using certain big endian conversion methods that don't exist in Net Standard 2.0.
I mean, I guess that's a separate conversation because most of it, I mean, the bigger problem is usually API surface. If the only thing you need to do is implementation wise, I mean, our UTF-8 one also grabs in some source files to basically aid the implementation. We could do the same thing here. I mean, I would not target Net Standard 2.1 probably. I would either do Net 5 or Net Standard 2.0 because Net Standard 2.1 doesn't buy you much in terms of reach. Because you already give up on .NET Framework, might as well just
2.0 might be tricky because I rely on many.
I mean, it seems like your consumers are all on Net 5 anyway, right? So if you would be Net 5, you would still be happy.
Yeah, the real question on that would be half, which I think we were only doing for Net 5 forward.
Right.
So would we need a split ref for this? But since Seaboard is less pervasive than dir, you may not have the need to make a Net Standard ref yet.
I mean, what I heard was that it's only needed in the context of ASP.NET, so in which case Net 5 would be fine.
Okay.
All right, let me scroll down then again.
Yep, one method left.
Yeah, write encoded value. So as you would expect, this basically just accepts a buffer that contains a pre-encoded Seaboard data item and injects it into the current stream. So it basically does all the validation to ensure that this is both a well-formed Seaboard value and also conformant to the conformance level of the Seaboard writer. So basically, it has all the semantics you would expect, but it can additionally throw an argument exception if you're trying to write something that is not valid.
Yeah, I know. I mean, I can almost certainly understand why you're currently taking read-only memory, which is the reader's going to take read-only memory.
Yep.
I think that you should play dirty tricks and turn a read-only span into a read-only memory to call the reader for validation, because read-only span is the functionally correct data type for this method.
Mm-hmm.
So
yeah, I could do that.
And if later you do what I did and make Seaboard decoder that's just a helper method collection, then you could get rid of the pinned memory manager.
So what's the conclusion here? Both or just one?
It should just instead of read-only memory, it should be read-only span.
Yeah, that's what I thought. Okay.
And while there is the implementation, or there's a mild implementation complication from that, it's a pattern we've worked around before.
All right, so then this is it for today. So one question I still have is namespace.
So that would be under system.formats.seaboard.
That makes sense. System.formats.seaboard.
Big C, little everything else.
That's what I assumed, yeah. All right, so that means we have the reader left. Can I assume that this is another 2 hours? Or do we think we can get this in 1 hour?
I think 2 hours is a good assumption. I mean, there's always more nuance in readers compared to writers, so would probably allow more time to discuss things.
It may be longer than 2 hours.
Oh, you're such an optimist.
When Eric suggested to me that he thought that it was going to take more than one session, I told him ASN took 2.5. So
yeah. So then let's set up so when are you back, Eric? You're going on vacation.
I'm back next week.
You're back next week. Cool. So then Tuesday next week?
Yep, that works.
Perfect. Then I see you next week. Enjoy your vacation, whatever you're doing. And
staying at home.
Staycation, the best vacation. At least you have a good roommate. All right, then, yeah, unless there's any more, then I see you guys.
Cool. Thanks, Simon.
Bye-bye.
Bye.